This is section 3.4. We are going to graph linear inequalities in two variables, okay? We're going to be working with things that fit this form. ax plus by is less than c. Now, just like the last time we did inequalities, I'm going to write our rules with less than, but it could be less than, greater than, less than or equal to, or greater than or equal to. It can be any of them, okay? And as with all inequalities, you will be graphing and you will be shading. That is a constant with inequalities. You're always going to be doing it. Okay, so I'm going to tell you the process here, and it may not make a whole lot of sense until you see an example, okay? So this will be mainly for reference after you've seen a few examples. What we want to do is we're going to draw a straight line that forms a boundary between the false side and the true side. So we're going to have some sort of line. One side of it, everything will be true, everything will be false on the other side, okay? Now this line that we're going to draw, we use a dotted line if we have less than or greater than, and we use a solid line if we have one of the equal to's, okay? So just like before, here we would use parentheses, now we're using a dotted line. Here, where we would have used brackets with one variable, now we're going to use a solid line, okay? So we draw this boundary line, and then we have to choose which side of it to shade. And then what we're going to do is we're going to choose a test point, plug it in, see if it works. It's not really that hard, okay? It's hard if you make it hard. Let's look at an example and see if we can get all this straight. The first thing you want to do is you have x plus y is less than or equal to -3. The first thing we do is we pretend it's an equal sign. X plus y is equal to -3. And we just need to get this thing graphed, okay? Don't let that panic you because you aren't told what method to graph with. Sometimes, often, we just have to get a graph done. And you have a bunch of options. I could pick just random numbers and plug it in for x and y and find points on that line. I can find my intercepts, hopefully by plugging in zeros, and hopefully I get 2 points. I could also rearrange things so that it is in slope-intercept form, and I would know my y-intercept and my slope, and I could graph it from there. I have a lot of options. My own personal preference is to use intercepts when I can. And if I get something that's a little bit uglier, or if it happens to be in the right form to use slope-intercept, I'll go with it. But if I'm given something in standard form, I usually try my intercepts first. Okay, so let's say x is 0. If x is 0, that x goes away, and my y equals -3. So that means I have the point 0, -3. 0, 1, 2, 3, -3. It's right here. Now I'll say y is 0. That means that y goes away, and I have x is equal to -3. So that would be the point -3, 0. -3, 0 would be right here. Okay, so I know enough to figure out the boundary line now. So I know my boundary line is going to look like this. What I don't know at this point is whether it is supposed to be a dotted line or a solid line. So I come back up to here, and I see this little line on it. And with the line, with the equal to part, we use a solid line, okay? So just graph your solid line. Okay, now what this does is it does separate things between a true side and a false side. And right now, I don't know which is which. One of these sides, any single point I pick in it, I could plug it in here and it would be true. On the other side, I could plug in every single point over here and none of them would be true. And I just picked random sides here. I haven't tested yet. So what you can do, there is a way of looking at it and saying, okay, well, if it's less than, it's supposed to be left or below. But then if you're like me, you start overthinking it and then confusing yourself and not being able to do it. So what I'm going to show you always works. It may take a bit more paper than what you're used to or what you're comfortable with, or maybe you learned this before and you never had any trouble figuring out which side to shade. I'm not telling you you have to do it this way, but this helps a lot of people. So if we know that all of one side is true and all of the other side is false, all we really need to do is to test one point. If I test a point over here and it's true, then this whole side is true. If I test a point over here and it's false, That means this whole side is false and this side must be true. Okay? So when I say choose a test point not on the boundary line, I don't want to choose something right here because that's not helping me figure out which side is true. I like something simple. If 0, 0 is available, I use that. Now this line does not go through 0, 0, and zeros are the easiest thing to plug in. That's why I choose this. Now, if my boundary line happens to go through the origin, I pick something else easy, like 1, 1, or -1, -1, something like that. Something around the origin is available, and you can use small numbers to check. So I'm going to use this as my test point. Now, I've drawn this in. This is technically not part of your answer. What you want to do is you want to take those coordinates, my test point, and I've just chosen this. It could have been any point as long as it's not on that boundary line. I'm choosing 0, 0 to plug in. And you want to plug it in over here and then ask yourself if what you get is true or if it's false. So if I plug in 0 for x plus 0 for y, that's less than or equal to -3. That gives me 0 is smaller than or equal to -3. And a negative number is never bigger than 0, right? So this is false. Since this was my test point and it was false, this whole side is false. So this whole side is true. That means any point I plug in over here will work. The last step is to shade the true side of the graph. Okay, so you will shade it somehow. Okay, when you're using MyMathLab and you're using the line draw tool, you have the option of clicking to make it solid or to make it dotted. So that's where you would make that choice. And you'll see a paint bucket so that once you've graphed this line, you can click on the paint bucket and click on this side and it will shade the whole thing for you. This is solving this inequality. Every single answer over here is a solution. We found all of them. We just can't plug them all in. Okay, so let's try. X plus 2y is greater than 0. Okay, one of the first things I notice once you start working these, this is something I noticed in the beginning, this is going to be a dotted line. And noticing it in the beginning helps me remember to actually do it when I get to the graph. Okay, so in order to find our boundary line, we need to pretend that we have x plus 2y equal to 0. Okay. So I'm going to try to graph this, and I'm going to try using the origin, or finding my intercepts, I mean. So let's say x is 0. If x is 0, that x goes away. I get 2y equal to 0. If you divide both sides by 2, you get y equals 0. So, and this is the case where we only get one intercept. Our x-intercept and our y-intercept are precisely the same. We cannot graph a line with only one point. We need a minimum of 2. So we need to find some other point, okay? You have options. You can pick a random number and plug it in for either x or for y, find its corresponding x or y, and plot that point. You can rearrange this so that it's in slope-intercept form, use the slope and the point you know, and build up and get the rest of the line. Let's just choose some other random number. Let's say y is equal to 1. It's a nice number to plug in, 1. And I'm choosing to plug into y because there's no coefficient here on the x, which makes it easier. It works the other way too, but this is just a little bit easier. So that would give me x plus 2 times 1 equal to 0. So x plus 2 equals 0. Move the 2 over, and you get x equals -2. So that means I have the point -2, 1. -2, 1 would be right there. So now draw in your boundary line. Remember that it's supposed to be dotted. Okay. And now we need to figure out which side to shade. Now we're going to choose a test point, and it doesn't matter what it is as long as it's not on this line. Now I told you I use 0, 0 whenever I can. I can't do it this time. I choose something else that's relatively small and easy to work with. So I'm going to use 1, 1. My test point is the point 1, 1. And if I plug this in and it's true, I'll shade this whole side. If I plug this in and it's false, I'll shade this side. So let's plug in 1, 1 into the inequality and see what we get. That will be 1 plus 2 times 1 is greater than 0. So that's 1 plus 2 greater than 0. 3 is greater than 0. And that is true. Okay? So I plugged in my test point. It was true. So this whole side is true. This whole side would be false. Okay? And I shade the true side as my answer.